Welcome to PGSMaths. In this video we're going to be looking at different ways to describe angles. When talking about angles, what we mean is a way of measuring how far something has rotated or turned. So, a good starting point would be to look at describing a turn as a full rotation from the beginning all the way back to where it started. So if we start at 12 o'clock using this clock as an example, this is called 0 degrees because we haven't turned at all. As we start to rotate, what we're doing is increasing the angle at which it has rotated. So when we get to 3 o'clock, we've gone a quarter of a way all the way around. This is called a quarter turn. We've gone clockwise, following the direction of a clock, 1 quarter turn. This is known as 90 degrees. Each time we go 1 quarter around this clock, we're going to be travelling another 90 degrees. So from 3 to 6 would be another 90 degree turn. 90 add 90 is 180. So to go half the way around our clock creates a half turn. A half turn around the circle is 180 degrees. So moving to 9 o'clock, another 90 degree turn gives us 270 degrees. And this is 3/4 of our clock. If we moved right back to 12, we would have completed a full rotation, which is 360 degrees. As well as being able to talk about how far something is rotated, each turn has a special name. We have examples here of the 5 main angle types, each one showing a different stage of rotation. If we have a look at that top diagram, it's only rotated between the two lines a small amount. It's created this very sharp angle, sharp point, and we call this acute. And this is the name given to any angle which is between our starting point and up to 90 degrees, which we said was a quarter turn. If we continue to this nice quarter turn, we create this corner shape. It's very easy to identify. This is called a right angle. It's always exactly 90 degrees and is represented by this little square. Anytime you see this square, you can automatically deduce that this has to be 90 degrees. Without it, I'd suggest measuring it. Once you've travelled past this 90 degree rotation, we get into this much fatter angle, and this is called obtuse. Say obtuse can mean a little bit thick or wide. So opposed to acute, which was a sharp angle, obtuse is a really big angle. And this is bigger than 90 degrees, but it's not quite reached a straight line. A straight line is exactly 180 degrees. 2 right turns, 2 quarter turns put together create this straight line, which is 180 degrees. So obtuse lies between quarter turn and a half turn. Everything else after this creates what is called a reflex angle. Now a reflex angle is an angle that lies between a straight line and 360, which is our complete rotation. So how do we use these words to start describing angles? Well, when you've come across a shape like this triangle, and each part is labelled with a letter, you're generally asked in a question to find out what or describe what an angle is. So if we have a look at this angle here, I'm going to say, what is angle A? No. Just no. The number of times that I've seen people doing this is unbelievable. That is not an angle A. A is the name of this point. The angle is the distance between these two lines. So how do we describe this angle that is created? We don't call it A. We could give it a letter. If we assigned a letter to the actual angle, that's okay. We could call that angle A. It's a different letter to the point, and that's okay. But we cannot name it after the points. So how do we use these points to describe angles? Looking at the same problem, we need to understand the terminology which is going to be used to talk about angles. Now I mentioned that this is called point A. It's just a point on a diagram. Generally, where two lines meet will create a point. So this here is point B, and this is point C. It's like giving a name to something to identify where it is. So it's saying this is the city where point A is. So it could be a starting point on a journey. B could be a second point on our journey. It doesn't mean it's a direction, it doesn't have a measurement, there's no distance, it's just a name. So if I wanted to know what this line here was called, I would use the 2 points which create it. And so this line is between points A and B, so it's quite simply called line AB. You can reverse the direction of the line and also call it line BA. That doesn't matter as long as you've used the points which create the line. But we want to know how we can use this to describe an angle. So if I look back at this angle here that I was trying to describe before, I'm not going to assign it a letter, we're going to use the points which create this angle. Now to get any angle, we know we need a start line and a finish line. So we already have line AB, so the other line which is used to create this angle would be this line, line AC. If we look at those two lines, they've created this angle between them. So describing this angle is quite simply just giving the 3 points that surround the angle on those two lines. So what we would call this is angle B A C. And then we put a little hat above the A. It's like a italic L to show that it's an angle above A, because that's where our angle is. Our angle is at point A, but it's created between points B, A and C. Again, you can reverse the letters, so it could be called angle CAB. Likewise, if we were to describe one of the other angles, for example this one down here, it's not angle C. What we would call this would be angle ACB with the symbol over the C. Again, you can reverse this to be BCA. Okay, here's our challenge of the day. I've made a diagram with 5 different lettered points on it. But how many right angles and how many acute angles can you find in the diagram? Can you name them all? Submit your answers in the comment section below. And if you have any other questions or requests for future videos, please remember to let us know. You can send us a message on Twitter, Facebook, or on YouTube, whichever one you prefer.